Wow. Hi everyone. Look at that. I just got a crazy screen glitch the minute we came on board. Welcome to this video. That was crazy. Let's try this again. We're talking about sums of fractions today. So we're moving on with all the things that we know about our fractions. We're going to be thinking about, hey, how do we add them together, right? Because that's what that means, is a sum. Oh, wow. We got some glitches going on. Hold on. Oh, well. Okay, cool. A sum means the idea of the answer to an addition problem, right? And then our fractions, those are the things that are parts. So actually, if we think about it, we're taking parts of things and we're putting them back together. Because remember, that's really what a fraction is. A fraction, oh, and I should use a better word with that. Fractions are equal parts of something, right? That's what we've been talking about this whole time. For example, maybe I take the number 1 and I cut it into parts. And I could do that with a model. So here's like the number 1, and I could cut it into 4 parts. And I could shade in 1. So that would be 1 out of 4. I could also take the number 1 and cut it into parts on a number line. So 0 to 1, same thing. Let's cut it into 4 pieces. And maybe I'll put my dot here, which is true. That'd be 1/4. So we're kind of thinking about this idea today about what happens when I have parts and I put them together. Like what would happen? I have a feeling this is going to glitch now. Yes, it is. That's all right, though. I think I have a solution to that. Buckle up. There's going to be weird glitches all moving along, right? Each one of these is equivalent to 1/4. So what would happen if I had multiple pieces that I had to add together? How much would I have? Okay. We're going to do that today, talking about the usage of a tape diagram. So let's do it. Let's dive into the party. Whoa, math time. Okay. Let's just play with a couple things first. Let's start with those fourths. So let's say we have 1/4 and we're going to add 1/4. Great. Okay. Tape diagram. So this is what I would do. I would be thinking about if if I'm going to think about putting these 2 fourths together, right, the first thing I realize is the denominators in both numbers are 4. So I'm going to make a model. Oh boy. I'm going to make a model that is cut into 4 parts. So again, middle, middle, middle. So there's 4 equal parts. And remember, each one of these is worth 1/4. That's its value. And then we can just go up and do some shading. This should be fun as I change colors. Yep, weird. Okay, so we have 1/4 up here. So I'm going to shade in one of them. And then we have 1/4 up here. So I'll shade in a second one. And if we really break it down and look at what I have, there are 4 pieces. I now shaded in 2. So 1/4 plus 1/4 equals 2/4. Kind of straightforward. That makes some sense. So of course, let's just try a few more out. Let's kind of play around with this. Next, let's see, we just did fourths. Why don't we do thirds? Let's say I have something like, or not thirds, I meant sixes. 3, 6, and I'm going to add 2, 6. Okay. So again, here we go. Here we go with the glitch. I'm going to go ahead and take these and put them together. So I'm going to start realizing that my denominator says 6. So I'm going to draw one model. I'm going to cut it into 6 pieces. So that means thirds first, excuse me. And then I just go down the middle of each one of those thirds, and that gets me 6. 1, 2, 3, 4, 5, 6 pieces. Now remember, each one of these represents 1/6. That's how much it is. They're all equal parts. They're all 1/6. It just so happens when I put them together, they make 6 out of 6. Now we're going to look at what we have upstairs in our numerators, right? And we see I have 3 6s. So I'm going to shade in 3 of them. So there's 1, 2, 3. Okay. And then I go over to my next number and I see that there's 2 of them. So we're gonna go 1, 2. And if I count how many I've shaded all together, well, we know there's still 6 pieces, but I shaded in 1, 2, 3, 4, 5 of them. So 3, 6 plus 2, 6 is 5, 6. Okay, that makes some sense. I like the feeling of that. It's moving. So let's kind of go ahead and try another one. Notice so far our denominators have been the same and they will stay that way. So don't worry, that's just really where we're gonna go with it. Oh, I thought maybe the glitch had gone away for a second. So let's see, what did we do? We did 4 6s. What are 8s? Let's go with 8s. Okay, so here, let's do this. So I'm gonna go with 5 8s and I'm gonna add another 5 8s. So I'm gonna say 5 8s plus 5 8s. So now let's think about what's about to go down here. So again, if I was gonna put these together, I'm gonna draw a model, and according to the denominator, it should have 5, it should have 8 pieces in it. All right, so let's cut that up into 8 pieces. So with 8s, let me get better at fixing this. With 8s, I can go right in the middle, and then the middle of each, so there's 4. And then if I go in the middle of each one of those, it'll get me 8. 1, 2, 3, 4, 5, 6, 7, 8. So remember, this is 1/8, this is 1/8. Each square is equal to 1/8, or rectangle. I guess they're rectangles. So these are all 1/8. And I put them all together into this piece. So now let's go up to our numerator. And our numerator says 5. So I'm going to shade in 5 of them, right? 1, 2, 3, 4, 5. Okay, that makes sense. So there's 5 8s shaded in. And then my second numerator is 5 as well. Oh, maybe I shouldn't have used green. Let's use blue. Okay, so it's 5. So I'm going to shade in 5. 1, 2, 3. Oh, wait, I don't have any more to shade in. I'm supposed to shade in 5, but I don't have 5 to shade. So don't worry, because guess what we get to do? Since we took a model and we cut it into 8 pieces, and then we filled in 5, and then we needed to fill in another 5, and we ran out of space, what we can do is we're just going to make another model. We can do the exact same thing. I'm just going to make a second model, exactly the same. Right? I'm going to cut it into 8s. So half, middles, and then the middles of all of those. So again, 1/8, 1/8, 1/8, 1/8, 1/8. It's like a song. Okay. And now let's go back to our shading. So we had 5. So we did 1, 2, 3, 4, 5. So if we think about what we have here, right, it's still 8s. But how many did we shade? We shaded 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So I have 10 8s. 10 8. So I actually have more than I need, right? It takes 8. You could look at this in any really way to help you think about what makes a whole. So let me use a couple examples. One, let's say we were making teams for soccer or something, and the team can only have 8 players. Well, what this says is we actually have 8 people, or excuse me, we have 10 people that want to play on one team of 8. Well, okay, that means we're going to have 8 out of 8 on one team, and then 2 people are going to have to go to another team, right? So we have more than the whole. So another way we could actually look at this is great. I kind of like what we're doing here. Another way this can be looked at then is we can write this another way. We can say we have 8/10, or remember this over here, this is 8 out of 8. And any number over the same number is always equal to 1, right? Because it's all of it. This is one whole thing. So I actually have one whole, and then I have 1 2/8 left over. 2 eighths. And we'll talk about this as we go along in this unit. So I don't want you panicking if you're like, what? This is a fine start for me. If we add them together, we get 10/8. So let's kind of look at what we learned from that, because there might be a little pattern we see. Like if we look here, right? We had 1/4 plus 1/4. We got 2/4. Notice the denominator. Notice the numerator. You seeing anything going on there? Here we had 3/6 plus 2/6. Again, notice what happens with the denominator. Notice what happens with the numerator. And then the last one, we said same thing. 5 plus 5 equals 10/8. So hopefully what you're seeing here is that when adding fractions, we actually don't even have to worry about the denominator. That piece stayed the same every time. Notice that? 4, 4, 4, 4, 4, 4, 6, 6, 6, 8, 8, 8. They all stayed the same. So there might be something for you to be thinking about in another way we can do it. We can do this tape diagram that we showed, or is there another way this can be solved? So let's do one last tape diagram. And it's going to go with 1/3 plus 3/3. Okay, so again, this is a tape diagram. So I'm going to draw and I'm going to cut it into thirds. Each one is worth 1/3. So I see that I need to shade in 1/3 up here. So there's 1. And then in the next, see, I'm trying to like skip this glitch. It's pretty good. In the next, I need to shade in 3. Well, I can already see I don't have enough. So I'm going to make a second model. 1/3, 1/3, 1/3. And again, we have to shade in, it's a color we haven't used yet. We have to shade in 3 of them. So 1, 2, 3. So when we put all these together, I have 1, 2, 3, 4 shaded in. And again, the denominator stays the same. So I have 4/3. Or again, notice this right here is 1 whole. That's the number 1 because it's all of it. So I have 1 and 1/3 left over. All right, I'm going to leave you at that. So there we are with our sums of fractions, thinking about how we can use this tape diagram. If it works for you, great. If it doesn't work for you, great. It's a wonderful opportunity to ask questions in class. Ask questions, right? As I always say, hold us accountable for teaching you. If it doesn't make sense, then you need to let us know and say, hey, that doesn't make sense. Can you explain it a better way, please? Or maybe another way. Maybe another way would be a nicer word than better. I don't know. We're trying our best, but I'm always down to find other ways to help you learn it. So always ask the questions. Thanks for your hard work. And as always, we'll see you soon.